I'm going to look at three different examples of the triangle inequality theorem. My first one is going to be this problem that basically says I have three different side lengths, and I want to know if I have those, will it make a triangle? So what I'm going to do is I'm going to do what the triangle inequality theorem tells me. It says if I add two of the sides together, it's going to have to be greater than the length of the third side. I'm going to start with these two and compare it to this. So I'm going to start with 20 plus 35. Triangle inequality theorem tells me when I add those together, it's going to be greater than the length of the third side, which this time would be 15. Well, add these together. It tells me that 15 is greater than, or 55 is greater than 15. True. So we think, yeah, this is a triangle. Well, then, what I should do is I should check a different combination. So now I'm going to look at, well, let's look at these two sides, the 15 and the 35 added together, and let's compare it to the 20. So now I'm going to take my two side lengths of 15 and 35. Triangle inequality theorem tells me it has to be greater than the length of the third side, which is 20. So this comes out to be 50. Yep, 50 is greater than 20, so that says yes, it's a triangle. But I should check the last one, which would say, let's take a look at these two as the two sides, and then here's our third side. So if I take 15 plus 20, triangle inequality theorem says that has to be greater than 35 to make a triangle. Well, add these together, it's 35. Is 35 greater than 35? The answer is no. Is this a triangle? Well, this example says yes, this example says yes, and this example says no. Therefore, answer to our question is no. Now, do we really need to go through and check all three different ways? My answer to that is no. I'm going to look at this first example that we did. We took, in my opinion, or this is fact, that we took the two larger pieces and added them together. I'm just going to focus on the largest one. If I take the largest side and add it to anything to it, is it going to be bigger than the smallest side? Well, of course it is. So that we don't really even need to check it because it's always going to come out to be true. I'll come here, now I'm taking, again, largest piece. I don't care what I add it to, and I'm going to compare it to the middle side. It's obviously always going to be greater, so I don't really need to check it. But it's this last example. Take those two smaller sides, add them together, and see how it compares to the biggest side. If the two smaller sides added together really are bigger than the biggest side, yes, it's a triangle. If it's not, no, it's not, like we have in this case. So I'll come here and I'm going to use what I'm going to call the shortcut. Remember, just take the two smaller sides, add them together. Well, here are two smaller sides. Add them together and see how they compare with the biggest one. So I'm going to have my 5 and my 7. Triangle inequality says it has to be greater than the length of the third side. Is 12 really greater than 10? Yes, it is. So does it make a triangle? Yes, it does. And we're done. Proved that it's definitely going to be a triangle. Now my last one, this one's a little bit different because this one says, I'm going to give you two side lengths in 6 centimeters and 11 centimeters, and I want to know how long could that third side be? Could it be 1 centimeter? Could it be 50 centimeters? Or what are all the different possibilities? What I want to do is, I want to take this and I want to look at it in two different ways. One time I want to look at the 6 centimeter and 11 centimeter as the short side of the triangle. So just to kind of picture person, I'm going to say, well, here's my 6 centimeter side, here's my 11 centimeter side. How long can this third side actually be? So I'm going to take this and take the two small sides. If I add them together, it has to be greater than the length of the third side. Well, I don't know how long that is. In the math, if I don't know something, I'm going to give it a variable. We call it x. So according to this, it says that x has to be less than 17 when I read that backwards. The longest that this piece right here, that red segment, can be, it can't actually be 17 centimeters. It has to be just under that. So that's one way we need to look at it. But then you have to come back, and next time you have to say, well, maybe these aren't the two smallest sides. Maybe this one right here, maybe that's the biggest side in the triangle. So then I'm going to come back and say, well, then I have to add the two small sides together, which would be 6 is one of the smaller ones, and then the other one, I don't know. Well, that's my x again. And those two small sides added together has to be greater than the biggest side, which is 11. Solve this inequality. So I'm going to subtract my 6 from both sides, and now it says x has to be greater than 5. And I forgot to put my picture up here, but now basically this is what it's looking like this time. Now it's saying, well, I'll draw the triangle to look similar to what it did last time. But now this time I'm saying, well, maybe this is the 6, and here's the 11, that's the long side, and then here's my question mark. How long is that? And like the question mark up here was, how long is that? And this time it says that, well, that shortest, or not the shortest side, but the one of the smaller sides has to be greater than 5. It can't be smaller than 5. Now what I want to do is I want to take these two and put them together because it has to find the range of values. So I want to give a range. So when I take these two, I'm going to put them together into one inequality. Start with your small number, put your x in the middle, and put your big number out here. Well, now you have to look at it. How does 5 compare to x? 5 had to be less than x. I just took the green inequality down here and basically flipped it. And then when you look up here, how does x compare to 17? Well, x has to be less than 17. Now you see that range. That third side can be anywhere from 5 centimeters all the way up to 17 centimeters, not including 5 or 17. Don't forget your labels in here. I kind of ran out of room, so I'm sorry about that. But we know that that third side, it could be 5.1 centimeters long. It could be 12 centimeters. It could be 16.99 centimeters. Anything in between 5 and 17, not including either one of those. That's going to conclude my example portion dealing with the triangle inequality theorem.